Okay, I'd like to continue our discussion in Unit 4 related to UI management strategies. And so in particular in Unit 4, we've really been doing a deep dive into a graphic user interface framework available for Java called JavaFX. And as we've stated already, one of the nice things about JavaFX is that it uses a contemporary or modern concept towards rendering and organizing our graphic user interface logic. So akin to the way that it works with web apps, which is the dominant and probably most influential approach to developing UI systems, or at least graphic-based UI systems. So here, I'd like to continue exploring the core components of JavaFX. And so we've already talked about the stage, and we've already talked about a scene, and we've already talked about the nodes that go into a scene that then gets put onto a stage. But let's talk about properties of nodes, right? Inside of this particular lecture. And so here we'll have just a quick introduction to the JavaFX property, and then we'll go ahead and give an example code. So here, a JavaFX property is a special kind of member variable of the JavaFX nodes. So JavaFX properties are typically used to contain node properties such as the XY position, the width and height, the text, the children nodes, and other central properties in JavaFX nodes. You can attach change listeners to JavaFX properties so other components can get notified when the value of a property changes. We could also bind properties to each other so that when one property value changes, so does the other. And so in this particular lecture, we'll explain how JavaFX properties work and how to use them. And so really what we're going to do is look at some example code. So in the property example we're going to look at here is we're going to show how to access the width property and the preferred width property of a JavaFX pane. So that's a layout element that's going to be a layout object, as well as adding a change listener to both of them. So notice one of the change listeners will implement using the the old school approach of an anonymous Java class. And in the second change listener, we'll go ahead and implement the event handler, the callback function will be expressed as a Java Lambda expression. And this is just to show how you can have the two different ways of achieving the same goal of defining your event listeners and your event handlers when an event does occur to a JavaFX property. So here we have our source code, and we'll look at this in IntelliJ in just a moment, but I just want to step through. So here we have all of our imports. So we're going to import our application because that's what we actually have to extend and implement. That's an abstract class, but it's a required concrete class for any JavaFX application. Here we're going to import some things, some of the properties. So that's inside of the beans package inside of JavaFX, and we're going to go ahead and get the double property. We'll get the read-only double property. We're going to go ahead and from the beans package also import from the value package a change listener and an observable value. So the change listener will go ahead and listen for a change on a property, and when it occurs, it will invoke or call the callback function that we associate as the second parameter. And so the observable value is the value we are observing. And so when a change happens to something that's observing, we'll handle that event. It generates an event, and we'll handle that event by calling the callback function. We're going to, of course, import a scene. All scenes need at least one layout object associated into it. So we'll go ahead and try something besides the VBox. We'll try a pane. So we'll import the pane, and then we'll also import the stage which is effectively our primary window that we will put the scene into, and in the scene we'll put the pane into. Okay, so we're going to define a class property example, and that's going to extend the application class. So we're going to have, we'll explicitly define a main method, where inside our main method, we're going to call the JavaFX launch method. And so the launch method is going to initially set up our stage, and then it'll invoke our start method and pass the stage that JavaFX initially constructs into our start method. So the start method is, of course, what we always have to implement whenever we build out any JavaFX application. So here we're going to have our parameter, which is the stage that gets passed in from JavaFX. I'm going to create a new layout object, a new pane. And here I'm going to go ahead and get the width property from the pane using the getter width property. And I'm going to save that as the data type. So width property is going to return back a read-only double property, which is what we imported here. So again, these are just examples of properties, node properties that we can go ahead and have access to. And if you want to see the full collection of these properties, you could always go to the JavaFX API to see what your collection of setters and getters are. But the important thing is, once we have a property, we can start binding listeners to them. And when we bind a listener, we listen for a change on that property. And if a change ever occurs, we can then define a callback function or an event handler that will define a set of actions to do in response to that change. So here, I'll take this with property and I'm going to add a listener to it. And so the listener here just knows. So in prior examples, when we're adding action listeners, we were waiting for an action to occur. And the first parameter was typically the action. And the second parameter was the event handler, or the callback function that gets invoked when that action occurs. So for these property listeners, anytime the property changes is effectively the event. So all we have to do is pass into it a callback function, so a function that defines what happens when that property changes. So there's only one parameter in these instances. So there's one of two ways I can do that. I can either use what's called an anonymous class. And so what an anonymous class is, and again, this was the older approach that we used to use. You'll see it's a little bit more verbose than the newer approach, which is the Lambda expression. But effectively, anonymous class allows us to define a class and invoke its constructor without having to have its own class file, or without having a hardened class definition. So effectively, this class that we're creating, we're using the new keyword. So the new keyword, recall, is always used when we invoke a constructor. So here we're invoking a constructor, but we're invoking a constructor on something that has not existed yet. And let me just be clear about this. This is something, this strategy I'm showing you here, just to set up one of these callback functions, is not exclusive to JavaFX. This is pure standard Java code, but this is probably one of the first times where it might become meaningful to do this. So I want to highlight, this isn't a JavaFX thing. This is just a Java thing, but Java allows you to define a class and invoke its constructor all in one line of code. And so if you do that, the reason why it's called an anonymous class is that class definition isn't saved anywhere else. So we can invoke that constructor this one time, and then it's never invoked again. The class definition doesn't exist after this execution of code either. It's just essentially garbage collected away. So we're going to invoke a constructor on a class that has yet to exist. So we're going to define it right here, right now. And since it doesn't get defined anywhere else, hence the term anonymous, because you can't find it anywhere else in the source code. And so here we're going to define the class. We need a class name. So we're going to call this a change listener. So effectively, we're calling the constructor on it. And so normally when we call the constructor, now another big thing I have to highlight is we're creating a class by invoking the constructor on it, but we're not using the class keyword. You use the class keyword when you're defining the class that's persistent. So for anonymous class, you can just call the constructor like you normally would, right? So this is a constructor invocation, and the invocation is using the same name you would use if you were defining this as a class. But so when the class is already defined, you don't have to define a code block to associate with it because that already exists as part of the class definition, right? Now, if it's an anonymous class, when we invoke it and this class doesn't have a definition yet, then we can define a definition for what this constructor sets up, what this constructor initializes by associating a code block with it. So notice we have an open and closed curly braces, which defines the code block that is now associated with this anonymous constructor. So a change listener, which uses and we're defining on our change listener a generic parameter type of a number. So a change listener is going to use a number internally, right? So here, our change listener has to have, when we go to send this to the add listener is going to try to invoke from this anonymous instance a changed method. So we have to have a changed method defined inside of this object instance we're passing in as a parameter. So we're passing in this anonymous instance that has a changed method. This changed method has this as a parameter. So it's going to take 1, 2, 3 parameters. The first parameter is an observed value, which is going to be represented by some number, right? So we're using generic typing here to say that this observable value here, which is going to take in some number as its data type. So we're going to have an observed value. We're going to have the old value number that's passed in and the new value number that's passed in. So 3 parameters, the property, effectively the property value, the old value of that property, and the new value of the property. And then what we're going to do in response to that, the method body is just going to do a system.out, show that the width property changed from this old value to this new value. Okay, so that's the old way that we would define these callback functions, right? We would construct an instance of an anonymous class that had the one method that we knew that the event listener was going to try to call and so it needs to have a changed method. Okay, let's look at the other approach here. So this is one way that we could do that. The other way is, okay, let's get the preferred width property. We'll save that into a variable, double property type. Then we're going to, on that property, call the add listener. So we're going to add another listener to a different property. And we're going to do the same thing fundamentally, but instead of using an anonymous class, we will use a Lambda expression, which is a anonymous function that doesn't have to be defined within inside of a class definition, or like what we had here. So here we could just define the parameters. Effectively, we could define that function that is the changed function here, but we can just do it in isolation of anything else. So here, this is our parameter list for that function. Then we don't even have to give this function a name, right? We just say these are the parameters. So we have some observable value. We'll call it the property. That's the property that we're running to look at. The old value, which is going to be a number, and the new value, which is going to be a number. And again, we're using the generic typing here. And then for the body, we'll do the same thing. So we'll have our arrow operator that illustrates the flow of these parameters into this code block. The code block represents the function implementation. the code block associated with this function. And so inside of the code block, we'll just do a system.out.print, and then we'll print out this line. So this and this are two ways to do the same thing. The first example is the way we would classically do this. And just recently, a couple of versions ago, Java has updated the core standard language to start supporting Lambda expressions, which are a very popular way of producing these higher order functions in other languages, such as JavaScript or such as in Python. Excellent. And so the idea here, though, is after we define these event listeners, we can then call a setter method on that property. And so if we set a new value into that property, that's going to cause that change to occur, which will cause the event listener to invoke either this changed method or this Lambda expression, and it will actually do something in response to this property being set. And so let's see if we have an actual example in IntelliJ, so we can run this and actually see what that looks like in actual code. So here, let's go to property. Let's close some of these. Okay, so inside of properties, let's look at the property example. So the property example here is we are doing all the imports we're doing before that we discussed. We have our main method that launches. We have the start. We're creating that pane. We're going to get the with property. We're going to do the code we already just discussed, where we create this anonymous class that has this changed method, because we know that if we pass the anonymous class, if it has an instance of this anonymous class, it's going to look for a method called change. Otherwise, I can just give it a Lambda expression, and it's going to use the Lambda expression as effectively the function to call, because there's no exterior class associated with it. Then we're going to go ahead and we're going to set that value. Okay, let's go ahead and run this. We've already talked about it. Let me grab this property example. I'm going to go to my example runner. This is where we're at right now. So I'm going to go into property example, and we're going to call the main method that. And let's actually go and run this. Give it a few moments as we go ahead and build. Oh, you know, I can't just do that. I'm going to have to import the class into this helper, into my runner here. So let me import so we can actually run this. And then Grader is going to build out the project. And here we go. And you could see what's happening here is each time now remember the property that and let me go back over it to this. Oops, not quite what I want to do. Now recall that the property that we set a listener on was the width property. So as the width of our the window here changes, notice in response to each of those changes, I'm printing to the console the old value and the new value, see? And so we could say, let me actually, so not doing it for the height, right? I didn't set anything for the height, so notice nothing new is printed out in the console. But as I actually, and here, let me get here, as I change the size, we could see that the size keeps updating as that value changes. Excellent. Then I'm just going to close out of that. Okay, let's get back to our slide. So really, the entire point of this presentation was just to highlight the fact that these nodes have properties, but just because they have properties, and you can find all the properties like the width, the height, the X, the Y, all the different various properties that are available to you. You can check the API documentation, but what's more critical and probably unique about these properties that are managed in JavaFX is that we can bind actions to occur if those property values change. And so that's what can give you a very responsive interface system, because again, we're talking about event-driven programming. So instead of a command-driven system where the flow of control of the application is performed by the algorithm, where the algorithm will do some computation and then it will prompt the user, hey, give me input before I can move on. We flip that, we reverse that typically in a graphics-driven application where events from the user will prompt the machine to react. And so that entire metaphor, that entire kind of flipping of who starts the processing and the computation requires this event-driven programming model. So just understand we can associate a listener to any one of the properties in our node so that we can have it react to the user's interactions with inside of our stage. Excellent. Is there any questions related to that?